Let's take a look on the merge sort algorithm here. Merge sort is under divide and conquer, and the problem is the sorting algorithm. We have a lot of sorting algorithms. If you notice that merge sort is the most efficient algorithm, where in terms of big O end up with n log n. Most of the sorting algorithms, worst cases, n squared. So we have done quick sort before this. Quick sort also under divide and conquer design strategy. So you can see that the quick sort, the worst case is n squared. The best case could be the n log n. But here merge sort is n log n, the worst case. Okay, for the merge sort here, we have two algorithms. The main algorithm for the recursive called merge sort, and finally we have another algorithm merge, actually in order to merge and sort that the list. And here the main algorithm for the merge sort actually to split into equally half sub array. In particular, we have the array and we split into half, divide into by 2 equally. This is actually the merge sort. And similarly to the others divide and conquer, for example quick sort also, we have one main algorithm and we have another algorithm called partition, in order to find that the partition value and split into 2. Here we have a merge sort, there is a main merge sort algorithm, and we have another algorithm actually to sort and merge that here. Okay, before we explains in both of the algorithm here, let's understand this merge sort first through this pseudocode. Here we have n greater than 2. What does it mean? N greater than 2, sorry, n greater than 1 here. So when the list, the size of the list, which is the n, must be greater than 1, which is at least 2. When 2, we can divide to 1 and 1, and more than 2 basically. And after that we have a array here. These are the main array. We have the inputs here, a 0 to n minus 1, the list here a. But in order to implement the merge sort here, we need 3 array. A, the main here, b also actually is for the first sub array, to store the first sub array, and another is the second sub array called c here. So we need a, b and c. The original is a, and finally it will merge back to the solution, original solution, which is the a. But the a now is supposed to be sorted. Okay, and the first is when this true, when n greater than 1, which is at least 2. So we need to copy a, the original here, a to the half here, half the array, to b, array b, with 0 to the n over 2 minus 1. And the second here is to copy the start n minus 2, n over 2 here to n minus 1. So we have 0 to n minus 1, which is the middle, and put into the b, and the middle put to the n minus 1, put into the c here. So we have to copy this, and after that this recursive call merge sort here, pass a, pass b, pass c here, and do this recursive until this false, when n basically equal to 1. We have only one element for the each sub array. It will stop here, and after that when we stop here, you will call that another algorithm called merge, where we pass the b, pass the c, and pass the a to the merge. And the merge algorithm here basically in general, where during the merging then, so it will sort that the list and merge, sort the list and merge, and back to the original one. Let's say we have the array here, maybe to make it simple, maybe we have only 4 elements here, 0, 1, 2, 3, and split into this sub array, and this sub array, this become from the a, become this b and c. Okay, and after that split again. When split again, become 1, and this one 1. So this is actually false. And after that, when this the sub array becomes 1 and 1 here, so we compare because basics for the sorting is comparison, pairwise comparison. Compare here which one minimum, which one maximum, means one smaller, which one greater, and do that the sort like exchange or swapping here, and finally we get sorted for each and merge back in order to get that the original A here, but the outcome here, the final the result for the A must be sorted. Just now we discussed the merge sort means algorithms to split into two sub array. We have the array A, the original, divide into two sub array equally, supposed to be called C or B and C, and after that pass to the algorithms, another algorithm under the merge sort called merge. This algorithm actually to merge back to original, but at the same time sort that the list. Okay, now we're going to understand the merge algorithm here is a part of merge sort here. So called merge here, we have to, these are input actually parameters. We pass the B, the first sub array. We pass the C here as a parameter, the second sub array, where the B basically 0 to P minus 1, which is a half, and the second half actually start 0 to Q minus 1, which is actually the complete array 0 to N, but here is half of the N. And the original array also A 0 to P plus Q minus 1, which is M minus 1 here, the original. Okay, and now we have here the condition under the loop here, I less than P, which is for the first array here, first sub array, and J compare with J less than Q, the second sub array called C here. So compare B and C, and if Bi start with 0 less than or equal to J, what happen? If less or equal to J, so we assign the Bi, because this is true, if this is true, I into the K, which is the original array, the main array A here. K start with 0, means start into the index 0, and after we increase 1, meaning that here, so when this true, meaning that the B is actually less than the C, the element C for the first array, true, then increase by 1, go to the second index, which is index 1 here, compared to the J, which is 0. Mean here, if this true, we compare index 0, 1 until the P here into index J, which is actually 0. When false here, meaning that for the C here actually less than the element in the B here, so we assign J to the A. So here is actually the process here is actually to find that the minimum put in the array A with index 0, 1 until so on and so forth. So this is a process of sorting, actually try to sort here. This is the idea of this. And after finish that, if happen that when we compare it, if I, so we have to update this, the current value of the latest value of I. So if I equal to P, let's say I 4, P equal to 4, then we copy that this the C here into the A here. Otherwise we copy the B just now, where actually this the A, C and B is already sorted into the A, so that we can get the A merged to the A, and the A will be the sorted array. This is the roughly idea of merge sort. So the important here if F here actually to compare with two array, which one minimum, maximum, the minimum put into the A, index 0, let's say index here, and after that for if the C is actually less than the index, the element in the index B, put the A here. This process of sorting here happen, and finally it will put into the A here, the array A actually to merge that the process of this merge sort. So in general, we can conclude that merge sort is divide into two half sub-array until the array become one element. So this is the terminal, one element. And after that, it will merge back to the 2 and 4 maybe, and back to the original array for this is A, but during that the merge here, actually the element is already sorted. Let us take a look for the merge sort based on this example. Just now I give you the overview, the idea behind the merge sort through the pseudocode. Now give you the example through the nodes, the same example through the node 832975154. Let's say this is the list. This called the main array A here, and the n equal to 8. So we divide into half. See 8 over 2 here, n over 2 become 4 here. So 4 and 4. So this actually 0 to n over 2 minus 1. This n over 2 to n minus 1 here. So according to the merge sort algorithm. Okay, now divide here 2 sub-array. Here divide by 2 here, 2 sub-array. So the first is 8329. The second sub-array, this could be the B. Okay, this could be the C, and this could be the A, right? And the second sub-array 715. And according to the algorithm, it will divide again until the constant n must be greater than 1. If 1 and stop, meaning that we have to divide here. This becomes 83 and 29, and this become 21 here, 71 and 54, and again. So this become 8, this become 3, this become 2, this become 9, this become 7, this 1, this split into 5 and 4 accordingly. So this concept of merge sort, divide into equally half of the problem. When we stop here, this is time to merge basically, in order to merge and sort the list here. And based on just our BI, if I less than P and BI less than equal to Q here, so this consider the B and this C. Compare which one. If this minimum and put into the A here, the array here. So this maybe is a backward here. This becomes 3. This become 8, right? This become this maintain. This 1. This 7. This 4. This 5. And after that, we have this merge just now and merge again here. Merge here, compare with this. Finally, we can get here, store into the A here, and this finally, based on this, when actually the merge and sort merge until we get back this, the original array A, but this sorted. This become 1, 2, 3, 4, 5, 7, 8. Okay. 7, 1, 1, 2, 3, 4, 5, 7, 8, 9. So this actually the list, the outcome or the result of the output for this merge sort become the A become sorted after the merging and sort and in order to merge, we have to sort first and merge into the A here. Now it is time to do the analysis after you understand that the principle or idea of merge sort through the algorithm as well as example just now. Now for the analysis based on the master theorem, what we discussed just now, because merge sort is divide and conquer, so we can make use of the master theorem in order to find that the shortcut, the big O for the merge sort here. So as a user, we have to have a kind of recurrence here, recurrent relation C of n to C C is actually denoted as comparison. Compare that, because sorting is about comparison, pairwise comparison. C n over 2. N over 2 means we have the n size divided by 2. So this is actually the divisions, the divides and conquer for both sub-array. Sub-array 1, sub-array 2. And 2 is actually 2 times, because in order to split into 2, we have 2 times concurrently. That's why 2 of 2 times C of n over 2 plus we have another algorithm merge sort here. Comparison merge sort here is end up with n, because every element we have to merge and compare. So that's why the n here. So now we have to identify what is A. A is equal to 2, B equal to 2, D equal to here n, because to get the n basically n power of 1, so D equal to 1. So we need to check here which one condition. So basically A2, B2 here, the specified condition number 2. So end up with here O n to power of D log n. So D is a 1, so n power 1 n. So we can conclude that this O n log n for this. This is actually the worst case of this merge sort. The worst case scenario of the merge sort is on n log n. So far, this is actually the most efficient sorting algorithm compared to others. The others algorithms, I mean the sorting algorithm like selection sort, merge, quick sort, other sorting algorithm end up with n squared. So for the merge sort is n log n. So for this also we can use as a normal way to get the big O back statistical method. We can use also to get the same, basically n log n.